Good morning. I'm Commander Atul Kumar Rohatgi, once again in front of you on behalf of IIE Delhi HVAC Talks. We will continue with this series, and today the topic of our discussion is going to be about air balance drawing and calculation. Air balance drawing is a very important aspect of air conditioning design, and yet it is something that is easily forgotten. The air balance drawings are made to check whether the fresh air that is coming to the compartments that is being sucked in but that is being taken in is enough to do the required pressurization of compartments. It also checks sufficiency of air for each compartment, and it checks whether inlets and outlets both are capable of carrying that air for each compartment, for each watertight enclosure in a ship, for each fire zone in a ship, and also for each citadel space. As I said, that it is a very important part of HVAC design, and yet it is something that is easily forgotten. Now, the next question is that when we do this air balance drawing, when do we make it, and what are the informations that it contains? It is prepared after completion of heat load calculations. In fact, in the heat load calculation, as a result of it, of doing the objective of heat load calculation is to get the cooling air quantity. It is to get the required fresh air quantity for every compartment. It is also used, the heat load calculation is also used for grouping of the compartments with AHUs, air handling units or air treatment units. And we have, once we have done the heat load calculation, we have all these calculation results uh, in the results of the calculation. However, the same is required to be brought to the drawings, because in future the calculations may not be available with the operators. The operators may not be able to understand them also. Whereas, in case if it can be brought to the drawing, it can be used subsequently for duct design. It can be used for air balancing. It can be used for commissioning, and also after major repairs of the ship or the building, it can be used for rebalancing of the air handling units and air systems. The applications of air balance drawing are odor management, that is smell management, infection management, moisture management, compartment pressurization, which cannot be done without doing the air balance drawing, hospital and pathological laboratories where infection control is essential, clean room applications where dust control is essential, and there are many compartments that need to be positively pressurized and there are compartments that need to be negatively pressurized. Hotels and residential buildings where smell or odor has to be controlled. The bathroom odor, the toilet odor should not come to the living rooms or passageways. Similarly, the kitchen odor should not come to the dining hall, and the dining hall odors should not come to the living spaces. Restaurants design air balance drawing is a must. Now, this is an example of air balance drawing and what it can do, and in case if it is not done, what is the effect that it can have. Let's assume that there is a ship or there is a particular building where we have switched off the supply fans. Air supply fans have been switched off, so there is no fresh air that is being sucked in. However, the toilets, they have exhaust fans, and those exhaust fans are running. So what will happen? In this case, the air will be sucked through whichever door, whichever hatch, or whichever any other opening that is available. Through them, the air will be sucked in, and the air that will be sucked in will be untreated air. It will be high in humidity. It will be high in heat. So all that heat and moisture will come to rooms that cannot be predicted, and it will lead to uncontrolled temperature and humidity issues. Now here we are going to discuss a few compartments where air balance is a must and how we do air balance. As I said, that we have to see sufficiency of air uh, that is the air that is coming into a compartment and the air that is going out of the compartment. The ducts have to be designed for these quantities of air, both for inlet as well as for outlet. Now, dining hall is a compartment that is normally next to a kitchen, and on the other side there will be a passage or there will be a other living rooms. The dining hall is required to be kept at intermediate pressure. That is, it has to be kept at a higher pressure as compared to the kitchen and at a lower pressure as compared to the living spaces or the passage that is passing next to it. So that the air comes, from the passage to the dining hall, and then from the dining hall it should go to the kitchen. So pressure difference will ensure that smell does not come to the dining hall and dining hall smells do not travel to the passes. Uh, we can see the supply air that is coming in plus the door leakage should be equal to return air plus door leakage that is going to the kitchen. Another example where we have to maintain air balance or we have to do this exercise. This is a wash place which has to be kept at a negative pressure. Now here some amount of supply air is being given, some amount of exhaust air is being driven out, and also because this compartment has to be maintained at a negative pressure, the air has to come from the passageway next to it so that smell does not go in the reverse direction. So in this case, the supply air plus door leakage has to be equal. The summation of it has to be equal to the exhaust air. Next, the kitchen or the galley. In SIFs, the kitchen is called galley. So the galley is to be maintained, or the kitchen has to be maintained at a negative pressure as compared to the dining hall. That means when the door to the dining hall or the servery hatch is open, the air will come from the dining hall to the kitchen. In addition, the kitchen is being supplied with some air, and the air is being exhausted out. And also, we can have makeup air coming in, and that is being driven out with the help of hood. Air in kitchen or galley will be high in humidity and will be carrying a strong pungent smell. This cannot be allowed to go outside. This space is therefore kept at slight negative pressure. Pressure difference will ensure that the air will always leak from the dining hall to the kitchen and will never come back, and therefore, thus the smell will also not travel backwards. Now, this is the example of air balance drawing that I'm showing. Let's say that we are talking about a compartment which is being called junior sailor's mess. We can see that there is a air quantity written 353 in red. This is the supply air that is being supplied to the compartment. Now this supply air which is being supplied, we have provided a inlet. This much air should be able to go out from the compartment continuously, and therefore we have to provide a lure of the required size, or we have to provide a duct of the required size and capacity so that this air can be removed. Right now in this case, a lure has been provided in the door, either in the door or in the partition bulkhead, in the partition boundary, so that air can go out, and this much quantity of air. So the lure has to be sized for this, and we will have to assume that there is a particular pressure difference. Normally, the pressure difference that is assumed is around 5 to 10 pascals between that means the room will be at a higher pressure as compared to the passageway nearby. So thank you. This is all about air balance calculation and design, which is an important part of HVAC design. As I said, that we cannot do any clean room design, any hospital design, any place where we would like to have odor management, infection management. We cannot design those kind of areas, HVAC, for those areas without having a good enough consideration, without going in for making the drawing air balance drawing. Thank you very much. That's it. I'm here in front of you. I was here on behalf of ISHRAE Institute of Excellence. If you would like to start a journey in the HVAC world and refrigeration world, do come to us, do talk to us. We can help you out. We can help you build up your skill, your knowledge. Thank you very much.